All right, let's just get right into it. AI agents are already out there making some pretty big decisions in the real world. We're talking executing trades, routing complex workflows, even approving payments. But here's the thing. Their reasoning? It's a total black box. And that brings up a really, really critical question. No, really, think about that for a second. An agent wires millions of dollars to the wrong account by mistake. Or maybe it makes a bad trade that just completely tanks a retirement portfolio. What happens in that moment? Well, the answer is actually pretty simple and kind of terrifying. The money? It's gone. The trade is done. Those things are permanent. But the why? The actual logic and the context the agent used to make that call? Poof. It just vanishes into thin air. You can't audit it, you can't debug it, and you sure as heck can't trust it not to happen again. This creates this just massive, gaping liability. We call this the accountability gap. And honestly, it's the core problem that's stopping us from using AI in our most important high-stakes systems. Right now, we're basically forced to trust the marketing claims from operators with absolutely zero verifiable proof. But what if we could fix that? What if we could actually prove what an agent knew before it was even allowed to act? Okay, so let's move away from the abstract and look at a concrete example. This isn't just a theory. We actually captured a real failure in the wild and made it permanent. So let's look at the data. This is from a real-world trace. Think of it like the agent's work log. We're seeing a faithfulness score of 0.89. Now, that's pretty high. It basically means the agent did its homework and successfully found the right information it needed to make a decision. So far, so good, right? And then this, an answer relevance score of 0, a big, fat 0. So even though it had all the right facts, the agent's internal logic completely fell apart, and it answered the entirely wrong question. This is exactly the kind of silent, catastrophic failure that's usually impossible to trace after the fact, unless you notarize it. This exact failure, the good data, followed by the terrible logic, was captured and then permanently committed to the BNB Chain testnet, which is a public blockchain ledger. So it's not some mysterious error anymore. It's a cryptographic receipt. It's an indelible piece of evidence that we can now analyze and, most importantly, learn from. So, how does this actually work? Well, the solution is an infrastructure layer, a kind of trust primitive that we call the agent decision notary. The whole process is a really simple but powerful loop. First, the agent's entire reasoning context gets crunched down into a unique cryptographic hash. Then, and this is the most important part, that hash gets committed on-chain before the agent is allowed to do anything. Then, the agent goes and executes its decision. Afterwards, the outcome, whether it was a success or a failure, is recorded. And finally, the agent's permanent on-chain identity and its reputation score get updated. Now, you might be asking, why use a blockchain for this? The crucial reason is that it provides an immutable, totally tamper-proof timestamp. It proves beyond a shadow of a doubt that a specific line of reasoning existed before anyone knew whether the decision would be good or bad. This just completely eliminates the possibility of an operator changing the story after the fact. There's no hindsight, there are no excuses. So this is about way more than just creating a better audit log for humans to look at. The impact here is systemic. This infrastructure creates something totally new, machine-readable trust. What you're looking at here is a fundamental shift in how we think about this stuff. Before, we had to just blindly trust an operator's marketing claims. Now, we can actually verify an agent's performance on-chain. We go from having a black box liability to a debuggable, permanent receipt. We go from anonymous actions to a persistent, accountable identity. Let's try to reframe this. Think of it less like an audit log and more like a credit score for AI agents. It's a real, quantifiable, verifiable reputation that gets built up over time based on actual proven performance. And this score isn't just for people to look at. This one simple primitive unlocks this whole cascade of new possibilities. It enables real agent-to-agent trust, where one AI can literally check another's on-chain reputation before it decides to delegate a task. It allows for verifiable marketplaces where agents have to compete on proven performance, not just clever marketing. And it provides the actual foundation for operator accountability, regulatory compliance, and, eventually, entire autonomous economies. The best way to think about this is as foundational infrastructure. Just like how HTTPS became the undisputed standard for secure communication on the web, this system of pre-action commitment and on-chain reputation is going to become the standard for agent trust. It's not just another app. It's the protocol that trust itself is going to be built on. So I'll just leave you with this question to think about. As we keep handing over more and more of our world to these autonomous systems, if an AI's reasoning can't be cryptographically proven, if it can't be truly held accountable for its failures, should we really be trusting it with the decisions that matter the most?